Hello everyone. My name is Michael. I'm from the Physics Students Council of the University of Münster, and I'd like to introduce you to the Master of Science in Physics, so the degree which I guess you are about to start this term. Now, usually we would have an introductory session at the beginning of the term about how the master is working, and would probably invite speakers for that from the various research groups. But as you know, things are a little different this term. Everything will be going online because of coronavirus restrictions, and for the same reason we're doing this info session this term as a video, which you're watching now. So yeah, I'll first of all welcome every one of you at the University of Münster or wherever you're watching this video. And in the next few minutes, I would like to tell you how the Master of Science is working, and also in general how studying physics at Münster is working. Now, what I'm going to tell you is the structure of the course according to the regulations which apply to you if you start in the summer term 2020. Now, if you enroll in the winter term 2020-2021, meaning in October, then different regulations will apply for you. For that, we will have a separate info session at the beginning of October. But if you're starting to study this term and if you're enrolling this term, then everything I will tell you now is what you need to know. Okay, so how does the master work in general? So it's a 2-year course that is structured in 2 parts. In the first part, which are the first 2 semesters or the first year, you will hear a number of advanced lectures, do some advanced theoretical and laboratory courses. And this is designed to give you a specialized knowledge in certain fields of physics. That consists of 4 modules. First of all, elective studies in physics, then 2 physical specializations, and the general studies. And as you can already see, this is not very specific. And the reason is that you have a lot of freedom in choosing what exactly is the content of the modules. In fact, 2 people can study the Master of Science in Physics at Münster and not have a single lecture in common, because there is a lot of freedom in what you can choose depending on what you're interested in. But it will have to fit this general structure here. So essentially, what you have to do is you choose 2 specializations out of 6. I will explain them later in detail. You choose a minor subject, which is not physics, that will then be your general studies. And you do elective studies, which essentially means you do a number of lectures and other things in addition in a combination that you want to do, which can be pretty much anything. And the second year consists of, first of all, the professional specialization in project design and the master's thesis. Essentially, that just means you will spend 1 year writing your master's thesis. There are administrative reasons for why it's split up into 2 modules. The idea is that the first semester is spent on getting to know your project, starting to work on it, and at the end you will then have a presentation. And then in the final semester, you actually finish your project and write it up, and then be a Master of Science. Okay, I'll probably start with the general studies. The general studies are a module which you can do in a subject or which you have to do in a subject that is not physics. For this, there are a number of options you can choose between, which are listed in the course handbook, which are geophysics, molecular biophysics, business administration, economics, psychology, and German as a foreign language. German as a foreign language is particularly recommended if you're not a German native speaker. So this is not a problem for the course itself because everything is in English, but still you can use the general studies to also learn some German. And what you have to pay attention to that among these 6 options you have there are 3 which you can only do if you already did them in the bachelor. Of course, German is a foreign language you can only choose if you're not a German native speaker. So that might not look like you have too many options. But in fact, you have a lot of options because you can also create your own minor subject. If you do a minor subject that is not a part of the list presented here, then you have to, this has to be approved by our Dean of Studies, which is Professor Kuhn. There are, however, some modules that are not officially in the course handbook, but that are already sort of generally discussed and approved. So you can just download the module descriptions from our homepage, have them signed, and then just do it, which are computer science and philosophy. So for these 2 minor subjects, there are preset options that you can just study. And what is also quite popular and generally approved as a minor subject is, of course, mathematics. Now, then the interesting part may be the physical specializations. So you can choose 2 specializations out of 6. Again, you can also create your own specialization, but unlike for the minor subject, this is not something that is done very often. And these are then the things you really want to learn about in a lot of detail, and which you presumably will also write your master thesis on. Typically, this is done in the first year, although I should emphasize that the structure I've presented before is just the way it's generally recommended. You do not have to do it that way. You can also already start doing your master thesis while you're still working under specializations. Now, the 6 things you can choose among, which I will explain in a little more detail later on, are functional nanosystems, nuclear and particle physics, physics of materials, nonlinear physics, photonics and magnetics, and the physics of low-dimensional solids. Now, those specializations are typically all structured in the same way, although there are certain details that differ between the specializations. For example, how many lectures you have to do, how many lab courses you have to do, and whether there are certain lectures that are that you have to do or that you can do but do not have to do. But in general, there is a certain part in which you do introductory lectures, which typically also have exercise classes, meaning they have to solve problem sheets. So, for example, if you do material physics, you have to do lecture Introduction to Material Physics 1 and 2. If you do condensed matter physics, you will do Introduction to Solid State Theory, and so on. Then there is a seminar, typically at least one, although you can do more. A seminar means that you will have to give a talk about a topic that you're assigned and that you can then get literature on and give a presentation on. Then there are a certain amount of laboratory courses, meaning you do experiments within the institutes on the topics of specialization. And there is an elective part. It varies between specializations how large that is and what exactly that includes. That can be you can do more lectures, you can do more lab courses, you can do more seminars, and maybe you can do an internship. And then at the end of the specialization, you have an oral exam about the content of the specialization that can be done with any professor from the specialization at any time. You will then talk to the examiner before about what exactly is examined, and the exam is really important because this is actually what determines the grade you get for that specialization. And finally, there are the elective studies. This is a module where you can just do any courses from the Master of Science that are offered by the physics departments. It can be seminars, that can be practical courses, it can be lectures with or without problem classes, essentially anything. They don't need to be connected to each other. They don't need to be connected to what you do in your specialization. Well, of course, they can. Essentially, you're just doing as many courses as you need to get the required number of credit points. So here you can just try a variety of things to see what you want to specialize in and what probably not. And even if you're focusing on one thing in a specialization, you can do something entirely different here. So since it is a module, there has to be a grade for it because there's a general regulation that there has to be a grade for any module. And therefore, you have to get at least 1 mark in any of the courses. For example, you do some course with exercises within the elective studies, and then you go to the lecturer and say, okay, I want to have this as my marked course for the elective studies, and then you'll get a grade for how good your problem sheets were. That grade is of no importance for the master grade. It's just you need to get some grade in some form. Okay, a really important book to look at is the course handbook, or in German, the Prüfungsordnung. This is where you can find details for the various modules and how exactly they are structured. I've shown here a German example, although there's also an English version. A link will be in the description of this video. And this tells you how exactly the module works. So for example, here I've shown functional nanosystems. You can see here that it consists of 4 parts. First of all, you have to do 2 lectures about nanophysics, which in total give you 4 credit points. You have to do 1 seminar. You have to do a lab course, that gives you 6 credit points, and you have to do some more things on nanophysics, which gives you between 2 and 6 credit points. So that would then be the part in which you can really choose between quite a number of things usually. Okay, there are certain general requirements. First of all, you have to do at least 8 credit points of practical courses in total. Typically, that will not be a problem because that's already ensured by the way the modules are set up, because each module will contain at least 4 credit points, or each specialization will contain at least 4 credit points of lab courses. Then one of the modules should contain at least 5 credit points of theoretical physics. And this is actually a very important part. In total, you need to have 60 credit points from the 4 modules from the first year. So from elective studies, the specializations, and the general studies. So if you have a specialization that gives you 18 credit points, you will need less credit points from the elective studies than if you have one that gives you 14 credit points. So it does not really matter how they're distributed among the specializations. Just make sure that in the end you have at least 60 credit points. Each thing you do will give you a certain number of them. For example, like a seminar will typically be 2 credit points. A day of being in the lab is maybe once, or a 4-day lab course will give you 4 credit points. A lecture that takes place once a week gives 2 credit points. You get additional credit points for exercise classes, and so on. And then there is the second year, although, as I've mentioned, it's not as if you are forced to do those things in 2 years and in exactly that order which I present here. This is a professional specialization and project design, which can be specialized lectures, specialized seminars, or lab work and self-study. Essentially, this is just the first part of your master thesis. So you learn about the topic that you will write your master thesis on. Therefore, your thesis supervisor is also in charge of this module. And it is finished with a presentation. So essentially, after you're halfway through your master thesis, you give a presentation of about what you've already done and what you're planning to do. And for that, you will get a grade. Again, that grade is not important. And then the really interesting part, the master thesis, which is actually 1 year, although it's formally half a year. You write your master thesis, which means you'll do an independent research project as a part of a research group. And at the end, you'll hand in your thesis, and the thesis will make up half of the final grade you get for the master. So that's really important, and you should really make sure you choose something you're interested in, because you'll spend a lot of time on this part of the course. Okay, organization. First of all, there is the quiz pos, which is really important to know about. This is an electronic system where you can register for all the courses you take. Make sure you register for all the courses. There is a certain period of time in which you can do that. And if you've done a certain lecture in a certain module, make sure to register it in QuizPos and make sure to register it in the right module. If you've done a lecture or lab course or something else and you have not registered on QuizPos for it, that essentially means that for administration you haven't done it, and you'll be forced to do it again. Trust me, I've seen that happen to people. So just make sure you register everything on QuizPos. There are certain exceptions, namely the oral exams or presentations. They are not registered to QuizPos, or the thesis presentation. Those are not registered by QuizPos. For this, you'll have to fill in a form with the person who examines you, and then go there to the examination office or the Prüfungsamt. Then the total grade for your master. So you have an oral exam for each specialization, and you will get a grade for your general studies or your minor subject in somehow. That depends on what exactly that is. And those combined will make up 1/2 of the grade you get for the master, and the other half will be the grade you get for the master thesis. Okay, starting to study. Since you're watching this video, I presume you're starting to study in the summer, and in general, it is possible in the master to start it both in the summer and in the winter term. What you should probably keep an eye on is that some modules are structured in such a way, or at least some courses are structured in such a way that it's better to start them in the winter. So for example, in condensed matter physics, there is a lecture solid state theory 1 in the winter term and a lecture solid state theory 2 in the summer term. And if you're starting in the summer, it's probably not a good idea to start with solid state theory 2, because the lecture will assume that you already know the things from solid state theory 1. But in principle, it's allowed to do that. It's just, probably you don't understand anything. And then the language. It's generally a degree that is studied in English. So all courses have to be offered in English as soon as there's one person in the audience that is demanding this. Now, if you have a course in which every single person in the audience speaks German and is happy to have the lecture in German, then it's also totally fine to do the lecture in German. However, if you do not speak German, then feel free to just ask the lecturer to do it in English, even if everyone else is German. Don't worry about it. They'll have to learn English anyway. Okay, so much about the general aspects. So as you know, some things are different this term. There are general restrictions on social contact at the moment, so teaching will be online this term, at least at the beginning. Things might change during the semester, and it might happen that at some point during the semester, teaching will be at the university again. The problem is just we don't know. That depends on the political decisions, that depends on the general development of the coronavirus spread, which is just impossible to predict exactly. So we'll start teaching online and see whether at some point there will be teaching at the university again. So therefore, courses will be on LearnWeb, which is the electronic teaching platform of the university. Now, of course, you have to register for the courses, meaning the lecturers have to know that you will be attending their course. It depends on the course how exactly that happens. Presumably, this will be done for many courses by just enrolling on LearnWeb. So you go on LearnWeb and look for the courses you want to do. You can find a list of all the courses in the lecture list, and then you enroll there. And then after some time, there might be a password on the LearnWeb course. If you need to enroll in a course that has a password, or if you just don't know how to register for a course, or if things are different for a certain course, then just contact the lecturer. They will be happy to help you. And for many master courses, the number of people is not that large. Lab courses, of course, are very difficult to do online. Therefore, presumably, they will be postponed. And what is also important, if you're not from Germany and you have trouble traveling to Germany, then at least for lectures, you will be able to do the online courses. Even if teaching in person starts at some point during the semester, you will be taken care of. Just contact the lecturer or contact the department and they will help you. Okay, after covering the general aspects, I will now explain in more detail the different specializations you can choose among. First of all, there's functional nanosystems, which I've shown the course handbook before previously. That's a subject where you can learn about nanophysics or nanotechnology or quantum technology. Münster has a specific research focus on nanophysics and also a number of research centers specifically designed for that, namely the Center for Nanotechnology and Center for Soft Nanoscience. And this is, of course, a specialization which you can learn a lot of things that are relevant for industrial applications. So if you're looking for a job there, but also there's a lot of research you can do about that. And what is special about this specialization is that there is a clean room lab course in which you can learn nanofabrication in the way in which it is also done in research and in nanotechnology industry. Then there's nuclear and particle physics, which is of course more about learning about the fundamental aspects of physics, but it's also something that is a strong research focus. In Münster, we have a research training group on nuclear and particle physics, more specifically on fundamental particle physics, which will give you the opportunity to listen to a large number of very specialized lectures on very interesting topics. This is a specialization in which you can choose between doing it in a theoretical way and an experimental way. So there are a large number of lectures, some of them very theoretical, like quantum field theory, the standard model, general relativity, things about path integrals, about quantum chromodynamics. If you're into that, you can do very theoretical lectures. If you say I'm more of an experimentalist, you can do lectures on experimental nuclear and particle physics, about how detectors work, how to apply nuclear physics in medicine. And yeah, then also do the exam on whatever you've specialized on within this specialization. Yeah, then there is the physics of materials. Münster has a separate institute on materials physics, which is doing research on physical properties of materials, how to find out about them, and how to design them. And within this or within the specialization, you will learn about how to study the physical properties of materials and what properties they do have that affects their thermodynamics, the mechanics, the crystal structure, and things like that. And of course, you will learn all the experimental techniques that are relevant for studying the properties of materials. And in this specialization, you can also do an internship. You don't have to, but you can. Okay, then there is nonlinear physics. This essentially means the studying the physics of systems that are nonlinear. If you don't know what that means, typically that means to study the physics of very complex systems that show phenomena like chaotic behavior or self-organization. And these are phenomena that can occur in a very wide range of physical systems, and therefore this is again a very diverse specialization in which you can choose between very theoretical and very applied lectures. So that affect things like nonlinear optics, which is done a lot in Münster, but also the physics of fluids like droplets or fluid turbulence, also biological systems, so like the physics of swimming bacteria and the way in which they show spontaneous self-organization or pattern formation. Again, you can, but do not have to do an internship. That can be something in industry, but they can also be interdisciplinary course on nonlinear modeling, because this is a very interdisciplinary topic that has links to biology, chemistry, and mathematics. Then there's photonics and magnonics, which again is an applied specialization that is done in the Institute of Applied Physics. That, as you can probably imagine, has two parts, namely photonics and magnonics. Photonics has a lot to do with lasers and light-matter interaction. So yeah, essentially doing electronics, but with photons. And magnonics, that has a lot to do with spin dynamics and the way in which you can use spins for technological applications. And again, this can but does not have to involve an internship. Yeah, and there's physics of low-dimensional solids, which is again a specialization in which you can choose between having a more theoretical or more experimental focus. Although you will have to do a certain amount of both, because there's a strong focus on also showing you the connection between theoretical and experimental methods. So you will do solid state theory, one lecture or two lectures. You will learn about the experimental methods of condensed matter physics, at least one lecture, at least one lab course, and probably a second lab course if you're into experimental physics. Okay. Also, as I've mentioned before, there are various options to go into industry, and there are also options to go abroad. So you can do one semester at a foreign university, or also 2 semesters if you want to. That can be done as an Erasmus semester at one of our partner universities, but that can also be done at a different university, which we will then need to get funding for example, by the DAAD. You can do an internship, which is known as a mini-research or mini-Forschung. That can be done in a research group here, that can be done in a research group at university in another country, that can also be done in industry. And that can be a part of a variety of modules. And you can write your master thesis at another university, and you can write in industry. Our university has a number of contacts to both foreign universities and to companies in industry. And often it's a good idea to just make use of those contacts which we already have. And it's also important to plan those things pretty early, because maybe take some time to organize them. You can contact Professor Cornelia Dentz about this, who is our industry officer, or Professor Alexander Kappes, who is our Erasmus coordinator. Yeah, and since we're already talking about who you can ask, I'm from the Physik Students Council, which in German is known as the Fachschaftsrat, and we are there for you to, first of all, organize a variety of things like summer festival and introductory events like this one. And you can always come to us and ask us questions about everything that is related to studying physics here, or you can write us an email and we'll typically answer it relatively quickly. And then there is the course coordinator, Professor Bracht, who can also help you with questions about the course, especially with administrative aspects like admission or which lecture can I do in which module and where can I get credit for that if I've, for example, done something at a different university. Then if there are specific questions that have to do with you being an international student and say you need a visa or you have trouble with traveling and so on, you can contact the international office or you can contact Die Brücke, or the bridge in English, which is specifically aiming at helping international students. Now, if you have more specific questions on certain specializations, or say I'm interested in this and this topic and would maybe like to do a project on that, or I want to write my master thesis on that, you can contact the lecturers and you can contact the research groups. And what you specifically should keep in mind is the Bachelor Master Day, which we offer at the beginning of each winter term. Here, all the research group will present what they're working on and will in particular present what topics they can offer you for writing a master thesis. So this is a very good opportunity to talk to them, to see all the things that are available and to find out who is your master topic, or which should be your master topic. And if you have any further questions, as mentioned before, just contact us at the email address, which is displayed here and which you can also easily find online. Yeah, so thanks a lot for your attention. And if you have any questions, just feel free to contact us.
Okay, so my name is Christine and I'm going to show you the course overview, the quiz post and the Learn Web. The course overview is where you can find all the courses of the VVU in this semester. Now in the beginning you normally enroll into this course overview, into the different courses, to get the password or information for the Learn Web course, where there's going to be all the information and scripts which are uploaded in the term in the Learn Web. And in the end, I'm going to show you the quiz post, where you have to enroll for the exams that you have to take in the different courses. So, to find the course overview, you will go to the English homepage, then you go to Studying. There you can find this thing which is called My VVU. Gonna click on it and log into the student portal. Now, in the services, you can find the HIS LSF. This is the page where you can find the quiz post and the course overview. But let me first show you the course overview. To find it, you will click on Courses and on Course Overview. Here you've got all the courses for this semester. I'm gonna show you how to enroll in one of these courses now in the course overview. So we're gonna pick Physics, go to Study Course Physics Master, and I'm going to choose Elective Studies in Physics. And here you have a list with all the elective studies in this semester. I'm just gonna choose this, for example, Dissipation and Fluctuations in Non-Equilibrium Systems by Professor Kuhn. If you click on it, you get some information, for example, which type of course it is, in which term it is held, the credits you're getting, the language. and also the date that it's going to take place. To enroll for it, you just go up here to apply or cancel application, and you just click apply, and then if you click it, you're enrolled into this course. So, to find the quiz pos, you go on the same page as the one where you found the course overview, but you click on My Functions, and then on Administration of Exams, the quiz pos. Now you can go on to Registration and Deregistration, and if you scroll down, you have to tick the box with I accept that you read the information above, then you go on Next. Now you can see the master that you're enrolled to. It would probably be Master of Physics. And there you find all the modules of the Master of Physics. And then you can just click on whatever you want to enroll in. And normally you can click on it and then you can apply or cancel an application again, like you did before. But it will just be open by the 20th of April to apply or cancel in the quiz pos for the courses. Now I'm going to show you the LearnWeb. To find the LearnWeb, you just Google LearnWeb BVU, and you click on the link. And there you have the LearnWeb. You can log in with your normal password and username. If you've logged in, you can find the search bar down here. You can just type in the name of the course that you're looking for, or also the lecturer, and then you can search for it. And if you found the right one with the right administrator and everything, you can just click on it and you get some information about it. And normally now it will be that you can just click Enroll Me and get into the course. But if you need a key, you just have to contact the administrator or the lecturer for the key. So then you just click Enroll Me, and then you're in the course that you wanted. And there's then normally the information about it, and also the scripts get uploaded a lot in these courses.